All right, welcome back. We are going to do chapter 3.3 today, I think, is what this one is. Yeah, 3.3. So we're going back a little bit today, and we're going to talk about polynomial identities today. Really what these are, we're talking about identities. It says a mathematical statement that equates two polynomials expressions is an identity if one side can be transformed into the other using mathematical operations. These polynomial identities are helpfully used when you multiply and factor polynomials. So these are kind of the nice ones to have kind of in your toolbox. If you're factoring or if you're multiplying out, that if you have these little ones in your toolbox, it can make life a lot faster. So you don't have to do the X method thing. You don't have to find rational roots, which you don't know what are yet. But you're going to find out here in the next couple days. These are kind of the helpful ones that if you can remember these different things and how these are set up, it's going to make your life a lot better going down the road and to help things out. So you got to have your notebooks out. There's going to be a pause here within the video, and I'll leave this up here, and I need you to write these down quickly. So there's going to be a pause right now. Going to kind of stop looking at me and write these down, and then I'll come back in about a minute and we'll talk about them. There was a minute. Okay, so difference of squares. And again, all we're going to do with these is these are going to help us factor, are going to help us multiply out a little bit faster, so to say. So the difference of squares. So when we're talking about the difference of squares, we're talking about two perfect squares, A and B, where if we factor them, they're going to be A plus B and A minus B. So for example, if you have 25x squared, your A value is going to be the square root of 25x squared, which is just 5x. Your B value is going to be the square root of 36y squared, which is just 6y. So then the result of that difference of squares is the factored A plus B times A minus B. And really, all of these become really about being able to find that A and B value first. And we'll show you how we do that in a minute. So that's the difference of squares. So when they're subtracted from each other. The next one is the square of a sum. Okay, so notice how in the difference of squares, it's a squared minus b squared. In the square of the sum, it's a plus b squared. When you expand a plus b squared out, in actuality, you're going to have a squared plus 2ab plus b squared. And on the last assessment that you just took, like yesterday or when you took that assessment, a lot of you had issues with this one, and you were just taking it was a squared plus b squared. It's not the case. You got that middle term in there because remember you got a FOIL. So it's kind of the shortcut method to do this when you expand it out. So those two you're kind of familiar with. Now the next two, differences of cubes and sum of cubes, again, where it gets a little bit tricky, but when we're finding zeros and we're doing these kinds of things, both of these things are very helpful. So the difference of cubes. The difference of cubes says that a cubed minus b cubed. That to factor that out, or if you expand that, or factor it, I guess, it's going to be a minus b times a squared plus ab plus b squared. And we find your a value. Your a value is the cubed root of the first term. Your b value is the cubed root of the second term. Okay. So for their example, they had 8m cubed minus 27. My a value is cubed root of 8m cubed, which is just 2m. Cubed root of 27 is just 3, so that's my b value. And we just plug the numbers into the formula. So the difference of cubes is a cubed plus minus, the difference of cubes, a cubed minus b cubed, is a minus b times a squared plus ab plus b squared. Sum of the cubes, so difference is subtraction, sum is adding. So the sum of the cubes is a plus b, same formula, just different symbols. A plus b times a squared minus ab plus b squared. Now normally, you wouldn't get notes when you're taking these, and I'd say, oh, how do you tell the difference between the two? How do you remember the difference between the two? We just figure out a way to do it. Obviously, you're going to have your notes when you're doing your assessments now, so it's really not going to be that big of a deal. You just need to know if it's a sum of cubes or a difference of cubes type of situation. And we want to really be able to go, at least with the first two, both directions. The difference of cubes and sum of the cubes, we're really not going to look at really factoring, doing that. We're just more going to look at kind of the expanding piece of that. Okay, so let's look at just a couple of examples. So we've got 2x squared plus y cubed, and then that whole thing squared. So since we know this is squared, this is the square of a sum. Okay, so it's the second one. It's this square of a sum. So the square of the sum says that a plus b squared is equal to a squared plus 2ab plus b squared. So the first thing I like to do when I'm doing this is I like to find my a value, really find that a value and that b value, but we've already got them. The a value is just going to be 2x squared. My b value is just going to be y cubed. And I just like to get into the habit of doing that. Okay, so now when we expand this, it's going to be a squared. So that's 2x squared squared plus 2 times a times b plus b, which is y cubed squared. Now we simplify. 2 squared is 4. X squared squared is x to the 4th. Plus 2 times 2 is 4. X squared y cubed plus y to the 3rd squared is y to the 6th. And that's your solution. And you're done. Nothing left to do with it. Expanded it out. The second one. All right, so we've got two things that are changing from plus to minus. Kind of go back and look at my formulas. It's a difference of squares. So this is a difference of squared. Oh, geez, what am I talking about? Okay, it is really a difference of squares. We're just going to go the other direction of it. We're given this part of it right here. A plus b times a minus b, that's what that is. Now we're going to go ahead and multiply this out. And realistically speaking, you could FOIL. You could FOIL this, but realize that when you have a plus b times a minus b, that really that is equal to a squared plus b squared. So what's my a value? Well, my a value is 3x squared. My b value is 5y cubed. Okay, so my result is going to be a squared. So 3x squared squared plus b squared, 5y cubed squared. 3 squared is 9. So that's 9x to the 4th plus 5 squared is 25, y to the 6th. Okay, so we've kind of expanded it out and got to then our solution. Okay. So now let's look at factoring them. So we're expanding them. Now let's go ahead and factor them. So again, the first thing I'm going to do is I'm going to identify it as one of these. Is it a difference of squares? Is it a sum of squares? Is it a difference of cubes? Is it a sum of cubes? Well, it's a subtraction, so it's difference. Are both 9 and 25 perfect squares? Yep, they're both perfect squares. Is m to the 4th and n to the 6th a perfect square? Yes, they are. Okay, so then this is going to be the difference of squares, 1. So again, just to kind of write it down, a squared minus b squared is equal to a times b, a plus b, and then a minus b. So I like to list my a value first. Now remember, my a value in this case, this is a squared. So essentially my a squared value is 9m to the 4th. But I need to know my a value, so I'm going to solve this for a. So if I solve this for a, I have to take the square root of both sides. The square root of a squared is a. The square root of 9 is 3. The square root of m to the 4th is m squared. So there's my a value. My b squared value is equal to, my b squared value is equal to 25 n to the 6th. So again, to find our b value, we're going to take the square root. So my b value, the square root of 25 is 5. Square root of n to the 6th is n to the 3rd. So there's my a value and my b value. And again, I just like to do this now because now it's a plus b. So that's 3m squared plus b, 5n cubed, and then 3m squared minus 5n cubed. And you're done. Okay, we've essentially taken that and factored it. Let's go down to the next one. Okay, so again, kind of evaluating it out, trying to figure out what we have. I've got a subtraction. Okay. Can I take the square root of x cubed and get something that's pretty nice? No, can't, but I can take the cubed root of it. So if I can take the cubed root of it, then it probably means it's this difference of cubes. Okay, and in this case, it is the difference of cubes. So we go back and look at our formulas, difference of cubes. So the difference of cubes says that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. That's kind of the factored form of that. So again, I like to find the a's and the b's first. So it's a cubed minus b cubed. So the x cubed is in my a cubed spot. So I know that a cubed is equal to x cubed. So we have to take the cubed root of it. The cubed root of a cubed, 3 divided by 3 is 1, is a. The cubed root of x cubed is x. So my a value is x. B cubed is going to be 216. So we have to take the cubed root of 216. You can do that on your calculator. You get a b value that's equal to 6. So now I've got my a and b values. So now I can go over here and I can write it out. It's a minus b, so my a value is x. So it's x minus my b value, which is 6, times, and I'm just going to do it, a squared, a is x, so x squared, plus a times b. A times b is 6x. B is 6, so b squared is 36. And there's your solution. You're done. You've worked it out as far as you need to work this one out. Next one, excuse me, don't only have to do these with numbers, or sorry, with letters in there. I mean, you can do it with numbers too. So again, you're going to evaluate kind of what's going on. So we've got 11x cubed plus 5x cubed. So we've got cubes and we've got sum. So this is going to be the sum of cubes. So just to write it down, now this is going to be a plus b, a squared minus ab plus b squared. So again, I'm going to find my a value first. So a cubed is 11 cubed. So the cubed root of a cubed is a, the cubed root of 11 cubed is 11. So 11 is my answer for that one. And I think you can figure out what b is then. B is just going to be 5. So now I fill in my formula. 11 plus 5 times a squared. So 11 squared is 121 minus a times b. It's 55 plus b squared. B squared is 25. Follow order of operations. That's 16. 121 minus 55 plus 25 is 91. Multiply those two together just to get a solution out of this one. 1,456. Okay, and we can find that answer with this one because of the setup that it has. Right? Really, that's what we're going to do today, and the best way to do these is by practice. So what we're going to do is we're going to go on to the next slide then, and in the next slide I want you to go ahead and evaluate these. Maybe it's you need to factor it, maybe it's you need to multiply it out. You got to kind of figure out which one are they looking for, or we're trying to expand it, so to say. So the first one probably looks like you're going to factor it, probably. Maybe not. Figure out what that one's going to look like, and then figure out what that second one's going to look like, just by kind of looks like you're going to expand them out. And see what you get for your solutions. I'll give you about 2 minutes. Okay, that's way too long. Like a minute and a half. And we'll just put on some type of music and take my face off of here. And then the answer will appear in about 2 minutes. Okay, so there are your solutions. First one was a difference of cubes, sum of squares for the second one. And again, I'd like to find the a and b values. There are those. If you need to look at it a little bit more, you can go ahead and press pause on this. Okay, the next one. Okay, now we're going to factor. Again, that's kind of what we just did with one of the two anyway. So now we're going to factor these different ones with these. We're going to do the same thing. Okay, I'm going to start staring in here blankly for about 2 minutes or so, and then the answers will appear. So go ahead and write these down, get moving with them. If you know how to do them and you get to the answers, you don't really have to wait 2 minutes. You're watching a video, so I mean, as soon as you get done, fast forward it up to where the answers are. All right, there they are. Now I'll highlight where the answers are so you can see the answers. So there are identities, and then how you go about doing these different polynomial expressions with identities. So that's what you're going to look at today. The assignment today is going to be a PDF of the book. You have to do the evens. Do the evens only. And this won't be submitted, so this is just going to be a PDF. You need to know how to do the material, but this is not an assignment that will be turned in. Just a PDF version. Just do the evens. I should have known this, but I don't. You're just going to do the evens 28 through 50. The evens 28 through 50. See you next time. Stay safe, everybody.